Wait, is it recording?
All right, 3-5 and 6, dividing a decimal number by a whole number. Raise your hand if dividing decimals is not your favorite subject. Okay, that's what I thought. Okay, hands down. Thank you for being honest. Now, what we're going to try and do is kind of demystify division of decimals. What does demystify mean?
Like, don't make it too hard.
Yeah, no, we're going to see, we're going to take out what is so scary about this concept, right? Why are we all dreading this? Can we get through this without having to fear this unit so much?
Yes.
Okay, so that's what we're going to try and do. Okay, all right. So let's look at a simple example. I have 3,256 divided by 15, and I want to estimate the quotient. What would I change those numbers into? You don't have to change both. You can just get away by changing just one. Manu?
I would leave 15
Okay, leave 15 as it is.
and change 3,000 to
56.
256 to 3,000.
Okay, let's do that. It's like you read my mind. Okay, now before we get to that, these two numbers have special terms, right? Special names. The first one is called the dividend. The second one is called the divisor. Now, there's always a confusion as to which one's the dividend, which one's the divisor. Okay, so again, one way to do that, if you see the EN here, do you see that? Come on. All right, it'll happen. It's not responding. Yeah.
Picking up on that.
And I can do it from here.
Yeah.
Multiplication.
It's okay. Right? Do you guys see the EN dividend?
Yeah.
Okay. So dividend is the number you are dividing into. So it's almost like the same sound. EN and IN have the same sound, isn't it? Right? So dividend is the number you're dividing into. Another way to look at more a second grade, not second grade, fourth grade, we are looking at it. It's the one that goes inside the house. Okay? So again, inside, into, and the N, they all tell you that the one that goes inside, and therefore it's the dividend, which means the other one has to be the divisor. Okay, that's the number you're dividing by, and therefore it goes outside. So let's estimate here. And Manu said 3,000 divided by 15, and what is that? That should be 200. How do I get that? I'm looking at the 3,000, and I'm looking at the 30. What is 30 divided by 15? 2, correct?
Yep.
Now, what am I left with? 2 zeros here. How many zeros here? No zeros. So 2 zeros minus no zeros will be 2 zeros. So I put the 2 zeros next to the 2. Alright? So the first thing you would do when you look at a division problem is what? Estimate, just like we did with multiplying decimals. Okay, now you have a kind of an idea of where your quotient is going to be. So if you end up with an answer that is 20 point something, you know that your decimal point is in the wrong place. Or if your answer is 2,000 point something, you know that your decimal point is in the wrong place. Right? Now that you have the ballpark, you can work towards that. You all with me?
Yes.
Good. Now let's look at an actual division problem.
Yeah.
We should know this one.
No, not yet. All right, so 3,256 divided by 15. That's what we started off with, correct?
Yeah.
Okay, now we estimated the quotient, and what was the quotient? 200. Okay, so just keep that in the back of your mind. Now, which is the dividend? 3,256. That's the number you're dividing into. That's the one that goes inside, and therefore the dividend. So I'm going to put that inside the house. Okay? And 15 will be my divisor. Okay. So, how many digits do you have here?
4 in total?
No, in the divisor.
2.
Okay? All right. So what I want to do is I want to look at the first 2 digits in the dividend. Okay? Now, how many groups of 15 do you have in 32? Lena? 2 groups of 15. All right. So I'm going to say 2 up here. All right. Now, what do I do with that 2? So it's 15, 2 groups of 15, correct? So which will give me 30. And how do I do that? 2 times 15 is 30. Now I subtract, you need to know the difference. And you subtract 30 from 32, and you get 2. All right. Are we done? No. You have 2 more digits to bring down, correct? Can I bring down both the digits? No. So one of the rules that you need to remember is you can only bring down one number at a time. Right? So always keep that rule in your mind. So which number am I going to bring down? The 5, okay. So I'm going to use that line and bring down the 5. Okay? How many groups of 15 do I have in 25 now, Troy? 1. So where do I put the 1? Just above the number that I brought down.
So there's 25 minus
All right, so 1 times 15 is 15.
25 minus 15.
25 minus 15 is 10. Okay. All right, we have 1 more digit to bring down, correct? Mika?
6.
All right, let's bring down the 6. I dropped it down, put it right next to the 10. Now I have 106. Tyler, you with me? Okay, what do I do now? What is the question you're going to ask yourself?
How many times?
How many groups of 15 are there in 106? How many groups do you have?
Oh, let's try 10.
What is it? Try 10. So 15 times 10 would be 150, a little over. What is 15 times 5? 75. So it has to be between 5 and 10. Caitlin, 7? All right. Now, are you sure? Okay, you're sure. Maybe I'm not sure. So I'm just going to try 7. Does it hurt to try 7? No. So I'm going to put 7 there. And what is 7 times 15? 105. It's okay. Right? 7 times 55 is 35. And then you have 3. 7 times 1 is 7 plus 3 is 105. Okay. I subtract and I have 1. Now, if this were 4th grade or 5th grade, you might stop right here and you would write your answer as, well, you shouldn't have been,
The fractions.
right, exactly. We don't do that in St. Hilda's. 217 and 1. Come on. Come on.
Laggy.
Yeah. Right? You would have said that, correct? Because there are 217 complete groups of 15, and then one extra, which is 1/15 of that full group. Right? Okay. Landon, you're with me, right? Am I moving too fast? No. Good. Okay. Now, what if I want to write this as a decimal number, and I don't want to write this as a fraction and then convert the fraction? I don't want to do all of that. Can I get to the decimal value right from here? Okay. Now, I brought down all my digits, correct?
Yeah.
Are there any more digits left?
You can break down.
Shh. Just answer my question. Are there any more digits left? Are you sure?
Not in the original problem.
Okay.
But, I mean, you can.
Wait.
Zero? If zero's a
Yes.
Yeah.
Yes. What's there after the 6?
Zero.
No.
A decimal.
Decimal. There's a decimal point after every whole number, right?
Yeah.
You don't see it,
But it's there.
but it's there. It's like God. So we have the decimal point
Decimal point.
and a bunch of zeros.
0, 0, 0, 0.
I'm just adding 3 zeros just randomly. Can I add 15 zeros? Yeah, it's not going to change anything.
I want to add.
Pardon me?
It's an irrational amount of zeros.
Irrational amount of zeros?
As in, like, it's never ending.
Okay. Now, the moment you see a zero,
To break it down.
There you go.
no, you move it up. You want to get it out of the way. You understand?
Yeah.
So I see the 0 after the 6 in my mind's eye. As soon as I see in my mind's eye, I put a decimal point, and what do?
Bring it
I
up.
move it up. And, come on. Okay, I moved it up. Now I'm free to bring down the zeros. Now remember, how many zeros can I bring down at a time?
1.
Bring down only,
1.
we talked about that, right? Only one number at a time. So I'm going to bring down the first 0. Oops. And put it right next to the 1, which is 10. Now the question is, how many groups of 15 do you have in 10? Yeah, you don't have enough groups, right? You have enough to form a group. Okay, so I can bring down the next 0, but remember, how many groups do we have? 0 groups, so I'm going to put a 0 up there. And now I can bring down the next 0. Now I have 100. And now can you tell me how many groups of 15 we have in 100? Landon?
How many is it? 15 and 100? 6?
Good, because earlier we said there were 7 groups of 15 in 106. So it's going to be 6. And what is 15 times 6?
90.
90. Subtract the 2 and I get 10. All right. Okay, now what we want to do is we want to get to at least 3 decimal places after the decimal point. Okay, so I'm going to bring one more 0 down, put it next to that, and now I have 100. Now we just did 100.
No, but you need to put irrational
Why do I need to put a 0?
at the top because you just did 100 minus 90 equals 10. So then you still have to do that properly.
Oh, I see what you're saying. Okay, now you don't ask that question. Remember the question you asked, how many groups of 15 there are in that number? You don't ask that question until you bring down a number. Right? Bring it down first and then ask that question. So I brought down the 0. Now I'm asking myself, how many groups of 15? And Phineas?
6 again.
6 again.
So it's a number.
So it's going to be 6. All right. Can I stop here? Because I have 3 digits after the decimal point.
How many do you want to convert?
I can do that. Okay. Now there's something else that's in the. If it's in the box, then it has to be important, correct? Okay. Let's see what it is. All right. So if you need to bring down more than one digit or one number, what do you need to do? Add a 0 on the quotient before you bring down the next one, just like we did here. Remember that? We brought that down, realized that wasn't going to help, so we added a 0 and then brought the next zero down.
So it was okay that we didn't put a 0 next to the 6 again because, like Troy.
You only brought one
yeah,
zero
we
at a
don't
time.
need to break it.
Correct. Okay? All right. Yes.
There's but since it's just gonna go on 666,
Mhm.
you can do like the irrational number thing where you put like a line above the
Okay.
6.
We're going to do that. So it's 217.066. If I round that to the nearest hundredths place, it'll be 217.07. Right? Now, as a general rule, round your decimal answers to the nearest hundredths place. Okay? Which means you have to get to the thousands place and then round it to the hundredths place. Now, one last thing to do before we move on. Let's check this answer compare this answer with our estimate. What was the estimated answer? 200. What do we have here? 217. Close enough?
Really?
Pretty close.
Only 17.
Yes. Cameron.
I don't get why you added 2 zeros after the 1. Like the 100 minus 90.
Yeah?
I don't get why you added 2 zeros.
I didn't add 2 zeros. I only added 1 zero. This 10 is the difference of 190.
No, the first.
The first one.
Yeah.
All right. I brought down the 0, right? And I have 10. And you ask the question, how many groups of 15 there are in 10?
Oh, none.
None. So what do?
Bring down the
You put a 0 and then bring the next number down. Now, here's my thing. How many of you have a better sense of dividing decimals compared to where you were 15 minutes ago? Does it seem less threatening?
Yeah.
Less scary?
When you break it down.
When you break it down? Okay. Now, again, do we have to do a few more problems to kind of master this? Absolutely. Oh, a few more to master this, right? But you have a better sense moving forward because it's not as scary as it seems. That's number one. Number two, any whole number that you deal with is essentially a decimal number. So if you see a decimal number, should that freak you out? No. Because do you freak out when you see a whole number? Not as much. So why should you freak out if you're seeing a decimal number?
We see it every day.
Right? Exactly.
Every whole number has a decimal.
Every whole number has a decimal. So if you are comfortable dealing with whole values, then you should be comfortable dealing with decimal values also. Okay. Let's try one more. Right. We probably take a couple of days, Ms. Fallon, that's okay, right? We always take a couple of days to do this lesson because we want you to become comfortable and do it well. Okay? Let's see. Okay, so we're going to take this up a notch. Just pay attention. 113.7 divided by 48. What is the first thing you would do? Stop yawning. Estimate. Good. You want to help me? 100 divided by 50. And 100 divided by 50 is going to be 2. But you know it's going to be a little over 2, correct? Because you're dividing a larger number by a small number. 113 is larger than 100. 48 is smaller than 50. So the quotient is going to be a little more than 2. Good?
Yeah.
Okay. All right. Now we know which one's the dividend. 113. And where does that go? Inside the house. And the divisor goes outside. Okay. Now, how is this problem different from the previous one? Alba? It has a decimal point. Again, should that scare you? Was there a decimal point in the previous problem? Yes. Yeah, I mean, you couldn't see it, but it was there. And you had to deal with it. Right? So if you're able to deal with it in the previous problem, you should be able to deal with it here.
It's basically just like multiplication. Just do it normally and then stick the.
All right, so I have my numbers, my division problem set up. Okay, how many digits do I have in the divisor? 2. So should I can start with 2, but is that going to help? No. So can I do 3? Okay, the first time you can take as many as you'd like. Because if you learn this in 5th grade, what do your teachers ask you to do? Put a 0 there. Right? Because 48 does not go into 1. Then you said, okay, let's take the next digit. 11. Does 48 go into 11? No. So they ask you to put another 0. And now you can look at 113. Now, do these zeros have any value? No. So I'm going to, I can just drop them. Phineas? Yeah, go ahead. Help me out.
So 48 goes into 113 twice.
Okay, 48 goes into 113 2 times. All right, so I'm going to put a 2 up here.
But aren't you supposed to put the decimal point first?
You could, but I'm also going in order. I will take care of it as I encounter the decimal point.
Because a lot of times last year they would
Say, take care of it. But just like when we did multiplying decimals yesterday, Mr. Fallon used the decimals, I dropped the decimals. You know? So you can you can have your own style. All right. So what is 2 times 48? Landon?
80, 96.
96, because 50 times 2 is 100, and that minus 2 will give minus 4 will give you 96. And if I take away 96 from 113, Manu, what should I get? There's 13 here, 4 here, altogether.
See?
Yeah.
Oh, you get 17.
17. All right. Now, what is the next thing I see after the 3? Ade, I haven't heard from you all day.
7.
No.
Oh, just
That's yes. What do you need to do?
you need to
Move it out of the way. Right? And how do I do that?
put it up.
Put it in my quotient. And now I'm free to bring down the 7, and I have 177. Okay. Right? And how many groups of 48 do we have in 177, Kate? Again, think 50. You, Kate? Okay. What is it?
3 times.
3 times, yes. Again, if you're wrong, you can always go back and erase it. And that's why you have a pencil and an eraser, right? If nothing is set in stone. So you, yeah. All right, so I have 3. Where's my 3? Okay, there it is. And 3 times 48 is?
144.
144. Good job. Subtract the 2. Phineas?
33.
33. Now, in terms of the process itself, are we doing anything different from what we did in the previous problem? No. It's the same questions. It's the same cycle that you do, right? You ask yourself, how many groups are there? Then you write that down. Multiply the divisor and that value. Write it underneath the number. Subtract. You do the same thing for every single step.
Did you guys learn in 4th or 5th grade about the loop? I don't know if they just started doing this, Miss Kiara and Miss Booth last year. I think they call it the DMS loop.
Okay.
Division, multiplication, subtraction. You just keep doing the same thing over and over again. DMS, right?
DMS?
Yeah. So that's all this is, but there's a decimal point.
Okay. All right. Now, if this were 5th grade, I would stop here, but I'm not going to. Hello.
We got like a minute or 2.
Oh, I see. Okay. All right. You guys need to Still early.
We need to be downstairs.
Okay. All right. So we'll stop here and bring down the 3, the 0. So remember, you don't have homework tonight. Okay. So the next problem we're going to look at is 20 divided by 96. Now, yesterday we addressed this a little bit. Some of us go into division thinking that the first number, being the dividend, always has to be bigger, larger than the divisor. But here is an example where your dividend is actually smaller than the divisor. Now again, should that trouble you?
No.
Should that freak you out? No. All right? Be calm. What is the thing? Keep calm and... Yes, keep calm and do math. Keep calm and do division.
AJ's
That's
teacher
yes.
says,
Keep
keep calm and call Batman.
Yeah.
That's right.
Your Christmas present is going to be keep calm and do math on.
Okay, all right. There's actually someone gave me there's actually a poster
Yeah.
that says keep calm and do math. We should get it. Okay, so again, first thing, keep calm. Look at the problem. Let the numbers talk to you. Okay? Now, don't change the order because the first number happens to be the smaller one. That is still your dividend. That still goes inside the house. 96 is still your divisor and goes outside the house. Okay, so the first thing is you estimate. Okay, you saw it already, but if you imagine you hadn't seen it, what would you change those numbers to? Simone, give it a shot, Simone.
100 and then 20 leave.
20 divided by 100, correct? Now, 20 divided by 100, if I write this down as a fraction, I think it will make more sense to you. Isn't that what it is?
Yeah.
Fraction is nothing but a division problem. Now, the moment you see 20 divided by 100, what are you thinking? Hugo? Sorry? 20 divided by 100. 100 divided by 20 is 5. What is 20 divided by 100? What number goes into 20 evenly? What number goes into 20 and 100 evenly? 5. So how many 20s do you have in 20? 1. How many 20s do you have in 100? 5. Do you guys remember doing this in 5th grade? Reducing fractions? Yes? Lowest terms?
Oh, yeah.
Yes? That's what it is, right? So I'm dividing 20 by 100 and it's not 1/4, it's 1/5. So it's going to be 0.25. No, 0.220.
I'll fix that while you're
Okay, no problem. Yes.
Okay, maybe I'm just obsessed with this, but I thought you did it 200. You do 20 inside the house, but then put a decimal point and put a 0 after the decimal point. Isn't that how we do it?
Well, yes, you're going to do that, but right now we haven't gotten that point yet. We're only estimating now. Okay? Now that we have a sense of what our answer is going to be, now we are ready to set up the long division. Ms. Fallon?
One thing, if you look back at this 20 over 100, right, and Father reduced it to 1/5, and because 1/5 is the benchmark fraction, we know that it's 0.20. If you said 20 over 100 just as a real fraction, not 20 over 100, but in real fraction language, what would you say? 20 what? 20 hundredths. Well, what's this?
Wait, she's 20 hundreds.
Yeah.
Yeah, 20 hundredths. What is this? 20 hundredths.
Isn't it? So you don't even have to think about, Mr. Fallon, you're saying you don't have to worry about fractions.
Well, I like the fraction too. I like the 1/5
Mhm.
because we need to know that 1/5 is.
0.2 or 0.20.
We should know that, but I think when you see 20 over 100, immediately you can just say that's 20 hundredths. and then you've got a decimal. You say it and it's a decimal.
It's a decimal. You guys see that? Say it and become. Isn't math fun? Like it's like doing magic. Like you say something in your head, and it actually happens in a different form. 20 over 100. If you say it the right way, 20 hundredths. Your hand automatically starts writing 0.20. Right? Okay. All right. You, Jax, can we just finish this and then I'll take your question. All right. So I have 20 point. I'm going to add a few zeros. I know that I'm going to need those zeros eventually. Right, Lucy? So I'm going to add those zeros and I'm going to divide by 96. All right, so let's ask ourselves the question, does 96 go into 20? No. So what do?
Do you make it 200?
No, you just.
That's what I was about to say. Move the decimal back.
Move the decimal back?
No.
You're thinking of something else. We will do that later, but at this point, let's keep the decimal where it is. Okay? But if you're looking for, are there enough? Do you have enough 96s in a 20? No. Okay, so Olivia, what would you do?
Well, 96 goes into 20 is 0.
Okay, 0 times, so I'm going to put a 0 there.
But you don't.
Let me just explain everything, okay? And then I need to take the next 0 on. But there is something that's blocking my way. What is that? The decimal point. So what do? I bring it up and put it right next to the 0. Now I'm ready to bring the 200. Bring down the 0. And how many groups of 96 do I have in 200? That's like saying how many groups of 100 are there in 200? That's 2. Right? So 2 times 96 is 192. Subtract the 2. I get, Lucy, what do I get? What do I get when I subtract 192 from 200? 8. Good. All right. So I'm going to do the 8 here. Now I need to bring down the next 0. And let's see what happens.
Father?
Yes?
18.
Sorry?
Isn't it 18? Oh, 192.
Yeah.
192. Okay. So I'm bringing down the 0. I make it an 80. And I find out how many 96s there are in 80. Victoria, how many groups of 96 do I have in 80?
Groups of 96?
0. Right? So I don't have enough there. So I'm going to put the 0 up there and then bring down the next 0. Where is that 0? Right, I'm just going to add the 0 there. Okay. Jesse, how many 96s do I have in 800 now?
I haven't figured it out yet.
No, again, think. How many?
Oh, well, if you could round 96 to 100, so then 8.
8.
That's why it took me so long.
Exactly.
8 and 32.
8 and 96, and that's going to be 768. Less 32. Yeah, less 32. Okay, now do I need to go any further?
No.
Why?
Because you have 3.
I have 3 digits there. I'm ready to round it to the nearest hundredths place. What would this be rounded to the nearest hundredths place?
I don't know.
Hugo?
0.21.
0.21. And I have my quotient. Jesse?
That's not.
Wait.
But if 96, 96 times 8 oh wait, I did it wrong, never mind.
You understand? Now look at the way Jax did. Jesse?
Yeah.
So he said, this is 4 away from 100. And there are 8 groups that I need to subtract. So 8 times 4 is 32. if I take away 32 from 800, I get 760, and that's what you actually have here. Teo?
Well, this isn't about dividing decimals, but is there a different name for
This one, you just say approximately equal to.
But we're still off because 96 times 8 is 768.
Correct.
So you're 32
Yeah, but it doesn't really
Yeah.
matter. You're 30. Yeah, but it's already rounded. I mean, I'm doing the workout just because.
But
just
if we did
to
this,
see, but
wait, if we did this method on a test, we wouldn't get points off, right?
Why? That's the method I'm teaching you.
We would get points off. We just didn't do it correctly.
Then yeah, I mean, it's not that you've used a different method, I'm going to take points off. But as long as your steps are logical and you get to the answer that we're hoping you'd get to, you're fine. Is this rational or irrational?
Well, what I did is I was trying to do 96 times 2 mentally, and I sort of just, I thought it was 182. Because
I see,
I
okay.
was just like,
Okay.
sort of,
All right, one more page.
It ends up being a repeated decimal.
It's a repeating decimal.
No, it is.
2083 repeating.
083 repeating.
2083.
Okay, so let's go back to the previous page. So you have 0. What do we have here? 0.208.
Yeah.
And the next one is 3.
The next one is 3.
And-
Because you bring down a 0, you have 320.
and then that's
And then
You all hear what Ms. Fallon said?
Yeah.
Okay, so he's saying it's 0.2083 083.
yeah.
No, no, no.
And you have to put the
There's a decimal point here, and then it's 20833333333. So the repeating starts right there.
Oh, I see. Okay.
Yeah, why do they different vowel?
Yes.
Why does sometimes one number always repeat except for like the whole one digit?
It's just the way the division works out. And we've seen it a couple times already, right? The same thing keeps happening. When you do multiplication, you get the same result. You subtract. It just happens over and over again.
Sophia?
I have a question. Is there a sign that you can put at the end of the problem to show that the problem still goes on? It's like forever. Like it's not like it ends there. It keeps going.
It's infinite sign, right? Yeah.
Well, if it's a repeating decimal, then you would put a line over that digit that repeats. Sometimes it might be one digit that repeats endlessly. Sometimes it might be 2, sometimes 3. But if there is something that keeps on going, but there is no pattern, there is nothing that we can say. All you have to do is to round it to the nearest hundreds or thousands place.
So it's like pi.
It's like pi, yeah. 3.14. You know that there are infinite digits after the decimal point. Simone?
When we're doing division,
Yeah?
how do you know when to stop doing the problem?
Good question. Now, why did I stop here at 32?
You didn't think you thought
Because I needed to have how many digits up here?
3 or
3. Right? So after the decimal point, I have 2, 0, and 8. I don't need any more than that. So that's why I stopped there. It almost seems like I stopped abruptly, but there was a method to the madness.
Okay.
Okay? All right. One more and then we'll be done. All right. Here's a practice problem. 3.006 or 3 and 6 thousandths divided by 6. Let's estimate first. Emily? Three divided by 6. What is 3 divided by 6?
No, because it's not.
It's not. It's.
What is 3 divided by 6? You guys know this.
Oh,
What is it? 3, 6 is,
Think of it as a fraction.
It's.
yeah? 0.5, 1 half. Isn't 3, 6 the same as 1 half?
Yeah.
Yeah.
Exactly.
And what is 1 half a decimal form?
0.5.
0.5. Okay? So my estimated answer is going to be 0.5. Okay? Now, where does the 3.06006 go? In the house. Where does the 6 go? Outside. Let's divide. Does 6 go into 3? No. What do I do? Put a 0 there.
6 goes into 35 times.
What is it?
6 goes into 35 times.
Okay.
You have to bring it
Alright, so there is a decimal point here that I need to move up. Get it out of the way. And, alright, so if it's not there, we're just going to.
I think I got the answer.
You got the answer?
I had the
Okay, alright, so I bring down the 0 now. Lucy, help me out, please. Walk me through the next steps. Okay, 5. And 5 times 6 is 30. What is the difference? 0. Then bring down the next 0. Is that going to help? No. Adding 2 zeros there just make any different. So what do I do here? Put a 0. Bring down the 6. And how many 6s do you have, Lucy?
Got it.
How many 6s do you have in 6? How many groups of 6? 1. Now, is that a terminating decimal? Meaning, does it go beyond this? No. Do I need to convert this to, change this to, pardon me, round this to nearest hundredths place? I could, but there's only 1,000ths after that, so I might as well just write it as 0.501. But if I were to round it to nearest hundredths place, what would it look like? .5 or 0.50. All right? Okay. Now, and compare your answer with the estimate. Very, very, very close, right? Exactly. It's just 1,000ths away.
You barely rounded your original number.
Exactly. Okay. Now, question. How are you doing in terms of confidence? On a scale of 1 to 10. 10 the best. 10 is like you're totally confident. 1 is not at all.
I think 8.
8? 7? Good. All right. Now keep in mind that when someone else is doing the problem, it's great. Right? You're understanding it. But when will this actually set in and become your own? When you do it. Right? So don't just take comfort in the fact that, oh, Father did it, Mr. Fallon did it, I got it. Don't stop there. Practice. We'll give you a few problems to practice this weekend. Practice, and then it'll become part of you. You'll start owning it. Okay? All right.